Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hi to my viewer and my panel, TS Muhammad Razali bin Muhammad Safi'i and TS Dr. Aliza binti Cik Amran. My name is Abdul Wafi bin Abdul Rahim from Bachelor of Electrical Engineering Technology, major in Industrial Automation and Robotics with honor. Now, I want to present my bachelor degree projects to present that is development of PID controller in conveyor belt system with different tuning method. In my poster, they have a 9 topic that I would like to explain to you guys. Now, I will explain about my project overview. The conveyor belt systems are a component of mechanical handling equipment that transport material from one location to another place. However, numerous factors influence or arise, and it will affect the performance and the durability of the conveyor belt system. Therefore, the goal of this research is to help prevent the problem from growing worse by developing PID control system in the conveyor belt system. Next, I will explain about my problem statements. The majority of conveyor machines used in the industry are still applying the old methods, which is it was incompatible with the current state of fast modernizations. The existing conveyor belt system do not have a monitoring system to assess the conveyor belt operation and efficiency, and the existing method for adjusting the speed of conveyor is very inconvenient or limited. Third, the objective of this project is to develop a PID controller to control speed of conveyor belt system by set a certain value speed. Next, the second, to analyze the effectiveness of PID controller on the system with different tuning method by monitoring the speed of the conveyor systems. And lastly, to build a GUI to monitor the speed and the value of PID control. Fourth, I will explain my methodology methods. This is my flowchart for this project. Firstly, when we start, we need to open up the Visual Studio. Then, we generate the GUI monitoring system for the PID controller. After that, we calculate the data PID with certain technique, which is Ziegler-Nichols or root locus and by MATLAB. Then, we put the calculated value of PID and set speeds into GUI monitoring system. After that, we run the program and the DC motor will be running. Meanwhile, the DC motor running, the graph will plot based on the speed of DC motor. Lastly, we analyze the data to make the observations whether it was same or not with the calculated value before. If it was same, it was a success. But if the value was very slightly different, we need to recalculate the data analysis before again to make a new value of PID. Now I will show you the GUI that I built from Visual Studio. This is because I using Visual Studio to monitor all the graph charts that have been plot during the DC motor running. This is for prototype for my projects. For this project, conveyor belt system with development of PID control with different tuning method. For this result analysis for this project, I made it with two different tuning methods, which is Ziegler-Nichols and reverse technique by develop the root locus and word plot methods. The main purpose for my result was to make the observation between two methods, which is theory by MATLAB and practically by Visual Studio. At first, I made the analysis of PID value with MATLAB simulation to a certain method till it was stable. Then, I will put the data collected to my project GUI to make the observation for checks the similarities and difference to make the analysis. Next, for this project features are: first, the push buttons are to control the operation whether it was starts or stops. Next, the conveyor belt was able to be used in different value of speeds, and the GUI show the data graph and the actual speeds. Next, for this project potentials are: first, it can use as a platform for the students, which is they can study the development of PID controller by practically. And for the system that used for this project, it can be commercialized to control the temperature, speed, and humidity. Assalamualaikum. Okay, and right now I will show you my prototype of PID, of conveyor belt system with development of PID controller. As we can see, this is panel control box, and then this is my conveyor belt system. Alright, I'm using a DC motor 12 volt with encoder. Alright, for the equipment that I use in my control box was two push button, and the LCD. Alright, to show the status of the programs. Okay, this control panel box I'm using Arduino Uno as microcontroller, and my motor driver LH290N for my DC motor. Okay, right now I will show you how to operate this prototype of PID conveyor belt system. Okay, as we can see in the LCD monitor, it shows the system stats. This is because it was in initial conditions. Okay, there is no previous program or any value set speed. Okay, right now I will show you the GUI for this project. I will start. Okay, I will set the speed for the max 100 for the KP 1.2, KI 0.8 for the KD 1.5. This project just to prove whether this program was connect to the conveyor belt system. Okay, I will send the data and start run motor. Okay. For the DC motor was running smoothly. Okay, right now I will show you the GUI. Okay, for the X-axis it was showed for the speed RPM, and for the Y-axis was for the time pattern. Okay, this graph was generated based on the smooth of the DC motor. Okay, right now I will show you the buttons. Okay, for this button it was start, right? So I will pause the process. Okay, we show the stop. Okay, the conveyor belt was stop running. Okay, and now I will resume the process. Alright, okay, we show the start, and the conveyor belt was running again. For the GUI, we show the break that I will show the example just right now. Okay, that's all for my video. Right now I will show you how to demonstrate for my result and analysis for Ziegler Nichols terminated and root locus terminated. Okay, how I get this graph, and then I prove it by my GUI, and this is my for the calculations. Alright, I will try. It maybe was slightly different because we cannot get the same graph, same value, but it was slightly same. Okay, for this, okay, I will try open up my MATLAB. Okay, I run. Okay, to find the set tangent. Okay, the tangent value was same as my transfer functions, numerator and denominator. Okay, this one. Okay, and for my okay, as you can show, okay, we need to find the value of x and l. This is because for Ziegler terminated, okay, we need to find the value of l and t. For the l was the delay time, and for the t was the time constant, which is the tangent line in between the inflection point with the steady state level. Alright, okay, right now I will try to find the value of l and t. Okay, okay, 0.268, 0.2625. Okay, it was quite same for the value, so I will explain for my formula. Alright, okay, to find the value of L, which we need to subtract between x2 and x1, x2 minus x1 equal to L. Okay, then we need to get the value of the ID value KPKIKD with this formula. Alright, okay, this one. Okay, so right now I will show you to prove with my GUI. Okay, I will try to run my GUI. Okay, I set the same speed as before. Okay, 100 kp equal to 7.4648, ki 0.0644, and tg 0.0161. I send the data, and then I will start run the motor. Okay, as you can see, the rest time was quite long to taken to get to the actual speed, to the set speed, which is 100. Okay, this is, you can look between this and this. This was very wide gap for the graph to reach the steady state level. Okay, as for the graph, why it become like this? This is because from the DC type of motor, it was used for the gear DC, and then this is because the PWM for the transistor, which is when it want to sustain to the speed, it read this with the PWM to affect the graph. Okay, right now I will continue for the second method. It was the reverse technique, where I develop the root locus tuning method with board diagram. Okay, right now I will show you how I get this data analysis. Okay, first of all, as we can see before, the settling time taken from this graph was very high. It was not good value for us. Okay, for PID. So right now I'm using this technique to choose a better graph reading. Alright, so right now I will show you how to step. Okay, I run for my program. Just put the drop function. Okay, wait for the block diagram. Okay, block diagram, and then the root locus. Okay, the root locus editor and the set response has been generated. Okay, right now I will show you how I get this analysis to be done. Alright, as you can see, this equation was kb s squared plus kp s plus ki over the s. So right now we need to change these equations from 1 to until this. So first of all, we need to add the differentiator. Okay, apple 0. So okay, we change. Okay, now we add another differentiator. Okay, alright. Okay, behind. So this was lack of s over s, so we need to add full integrator. Okay, so as you can see, it was same like this. So we need to find the stable one. Okay, so I just refer from this data. Okay, from this data. Okay, 0.7, 16 and 10. Alright, okay, I will try to find it. We'll just like this same value. Okay, now we need 10.05, 10.05. Okay, 10. Okay, this one is my system. Okay, system. If I want to do a new analysis, I just undertaken to make to show in this video, so I need to prove how analysis I did done. So this is my method to show. Okay, and now I need to change this to 0.7. 0.7. Okay, alright, 0.76, 0.75. Okay, we can change. Don't worry. 0.75. Alright, 0.73. Okay, as you can see, the settling time was decreased at 0.5. Okay, we can see the settling time by this characteristic. Okay, very good. So the settling time was 0.463. Okay, right now from the previous process we got this equation, and then we put it with this formula to calculate the KP, KI, KD value, and then this one that I have calculated. Okay, right now I want to prove with my practical theory with Visual Studio. Okay, I insert the value 20.38. Okay, KI 128.628787, KD 0.7464. Alright, I send the data and then I run the motor. As you can see, the graph was more better with this tuning method. The rising time was very short, and yeah, the time taken to graph to get the steady state was very quicker than the first theory method. Okay, that's all for my explanation in demonstration. Thank you. Lastly, I will explain for the conclusions in terms of developing of the ID control systems, analyzing the data using different tuning methods, and establishing a GUI monitoring system for a conveyor belt systems. This project has accomplished all of its objectives. Based on this project analysis, show the root locus tuning method have a better result, and it was suitable for implementing PID controller in practical. This is to my reference that I use for completing this project, which is feed forward and feedback DC motor control method of control systems by Africa, AD.M ETL, and design and implementation speed control system of DC motor based on PID control and MATLAB Simulink by Hamodi, SJ, Fly K, S, and Hamad. That's all from me. Thanks.